Hello everyone, welcome to IIT Gate classes. This is your lecture 7 on TOC. So in this lecture, we are going to start the construction of context-free grammars. Okay, so construction of grammars topic we were seeing, and we have already completed construction of regular grammars. And in this lecture, we are going to start construction of context-free grammars. Okay, so the first question is equal number of A's followed by equal number of B's. So first thing you have to remember is that infinite comparison. See, if we have infinite comparison, then the language is not regular. For example, if I say L is equal to, okay, L is equal to a power n b power n such that n is greater than equal to 0. This is the language see, this is the statement, and this statement can be written in the form of language or in the form of set as a power n b power n such that n is greater than equal to 0. So now here we have a comparison between number of A's and number of B's. So this is what I am saying, that whenever we have comparison, and that to infinite comparison, then the language is not regular. Okay, so what do you mean by infinite comparison? See, let us say if I take example as a power n b power n such that n is less than or equal to say 1 lakh, and n is less than equal to 1 lakh. Okay, yeah, or 10,000, whatever value you can take. The main thing is that it should be finite, so it should be finite value. So here we have finite number of comparison, we are not doing infinite comparison. Okay, so language will contain strings of the like this. So here language will be L is equal to null, okay, a b, then double a double b, then triple a triple b, and so on up to a power 10,000 and b power 10,000. Okay, so here we are not having infinite comparisons, we are having only finite comparisons. Okay, so this is obviously regular, and you have to remember one important fact, that any finite language is regular. You can take any finite language, whatever language you can take, any finite language is regular. Any finite language is regular. You have to remember this fact. Okay, so since this is a basic course, this is not advanced course, so I'm not going into the proof of all these things, but you have to remember this fact, that any finite language is regular. You just say any finite language, I will say that it will be regular. Okay, so I hope I have made the point clear to all of you. So here please remember this thing, infinite comparison. Okay, so in finite language, we will have finite number of comparisons only, so there will be no problem. But whenever we have infinite comparison, then it won't be regular. Like equal number of A's, equal number of B's, and so on. Equal number of A, equal number of B, equal number of C's, and so on. Okay, so whenever we have comparison, then language will not be regular. Okay, so now equal number of A's followed by equal number of B's. So now we want to construct a context-free grammar which can generate this language. Equal number of A's followed by equal number of B's. Now, okay, so let me design a grammar for you. Okay, so the grammar will look like, see, grammar will be say S implies, see, if I write AS, then obviously we can have any number of A's. Now we cannot have control over B's. Or if we write BS, S implies BS, then we can have any number of B's and we cannot control A's. Okay, so if we write even ASBS, then again the same problem, that we can have any number of A's, any number of B's. That means we cannot control that these number of A's and number of B's are equal. So we will write like this: S implies AS for A's, and now apply B here. So as soon as you apply B here, now I can guarantee that whenever I will apply this production rule, I will have A's and B's as equal, because one time if you apply, then AB, then second time, then again AB, and so on. Okay, so it will produce equal A's, equal B's, and stopper here will be null. Why we have null as a stopper? Because we want equal number of A's followed by equal number of B's. So language, this is a statement, and mathematically I can write like this also. So A power and B power n is greater than equal to 0. So if we put n is equal to 0, then obviously we will get null string. So null should be accepted, or you can say null should be generated by the grammar. Hence, S implies null should be present. So as a stopper, we are taking as null. Okay. Okay. So let me derive some two or three strings so that you get clear cut picture about how this grammar is working. See, if I write ASB, now first time I have applied this production, so I will get ASB. Now I will substitute this S as A again ASB. So AB we were having. Now this S is replaced by ASB. So ASB like this. Okay. Now again, if you want to replace, S by ASB, then how we will substitute? See, double A, double B we are already having. Now this S will be replaced by ASB. Now if I want to see, this is a sentential form. Please see it carefully. This is a sentential form. Why? Because we have a non-terminal here. Now I want to remove this non-terminal. So to remove this non-terminal, I will replace it by null. So whenever I will replace it by null, then I will get string as triple A, triple B. And in the middle, I will have null. Please remember this fact. I will use it again and again in this entire lecture. So in the middle, we will have null. So we will ignore this null, and our string will be triple A, triple B. So I hope I have made the point clear how triple A, triple B is generated. So again, I am repeating ASB. Now this S will be replaced by ASB. So in the middle, I am doing all things in the middle itself. Okay. So whenever I have applied this production rule one time ASB, then obviously the string will start with A and with B. Okay. Now this S will be replaced by ASB and so on. I hope I have made the point clear. Please note it down fastly so that I can jump to next slide. Pause the video and note it down. Okay. So now let's move to the next slide. Okay. Or let me do it one more thing. I will try to put it this entire thing on one slide so that you can note it down. Okay. Now let's move to next slide. Okay, next question is a power n, b power n plus 1 such that n is greater than equal to 0. How will you generate grammar, or how will you write grammar generating this language? Again, very simple. See, the basic idea here is just try to match A's and B's, and then you can think about extra things. So S implies A S B. I will make a power n, b power n. So in all such questions, you just try to first make equal A's and equal B's, that is a power n, b power n. Now ASB. Now you need one extra B. So one extra B means what? Stopper will be B. That's it. Okay. So I think this should be just like a toy for you. Just try to play with it and just try to find why this grammar is correct grammar for this language. Okay. This is homework for you. Just try to generate some strings and match and so on. Please do it yourself. Okay. This is homework for you. I have designed the grammar for you. Okay, now let's move to next question. Now next is a power n plus 1 b power n. Okay, so if you are not able to get this thing, then obviously you will get it here. A power n plus 1 b power n. Please pause the video and please try to construct grammar yourself. Again, I'm saying same thing again and again. A S B, so that A's and B's are equal. Now stopper will be A because we need one more A. Okay, I hope I have made the point clear. Okay, now just tell me one thing. If you are if you have concept clear, then where this A will be placed? Where this A will be placed? This A will be placed in the middle itself, like this. ASB. Now this S will be replaced by ASBB. Okay, or let me do it properly for you. Write AB. Now this S is replaced by ASB. Now this S will be replaced by A. Now this A will come here. Let me use a different color for this. A. So sorry. Like this. AABB. And this A is coming in between. Please note it down. This fact is very important. If you remember, if you are able to follow this thing, then the rest of the questions will be very easy for you. Okay, so this A will be placed in between. Now let's move to next question. A power n, b power 2n. Again, very simple. This is very simple. This is I can keep this generation of grammar or writing this grammar as a homework for you, but still I am writing it. Okay, so just note it down carefully. AS double B or null, that's it. Because number of B's are twice the number of A's. So S double B or null. Please note it down. And this is homework for you. Just try to match that why this is correct or not. A power 2 and B power n. Again, very simple. So please pause the video and make yourself. So double A SB. I hope you have guessed it right. Okay, double A SB. Why this is right? This is homework for you. Please try to play with it. Take some strings and so on. Next is A power 3 and B power 5 n. Again, very simple. Just do it this way only. Triple A S 1 2 3 4 5 times B. That's it. And stopper will be null only because null string is present here. Null string is present in the language. So this grammar should generate null. I hope I have made the point clear. This is very simple cases. Next is A power n, B power n such that n is greater than n. Yes, this is good question. Now just try to think about it. Okay, please pause the video and make the grammar yourself. Now I'm showing you the exact procedure how to write grammar for this. See, first thing is again same thing. Please try to match them. A S B. Now we have equal as equal B's. Now A should be more now, but how many more is we do not know. So just write like this: A, okay, and A goes to A or null. That's it. Okay, so ASB, you will keep on writing this. So equal is equal B's, you will get equal is equal B's. Now after getting equal is equal B's, now you will run from S by applying production rule, or you will substitute S by AA. Now this A will produce any number of S. Okay, so I can say like this also: M times you apply this. See, if you have string like A power 5, B power 3, now I will say three times you will apply this production rule ASB. Okay, so you will get triple A, triple B. Now S will be substituted by small a capital A, and this A will be replaced by small a capital A, and this A will be replaced by null. I have given you the procedure. If you are not able to follow, then please rewind the video and watch it again and try to make it yourself. And this is homework for you, and you have to check why this is correct. Okay, or if you think that I have done very in a very fast manner, then okay, let me do it for you. Okay, so S implies, see, I will write here ASB. Now this S will be replaced by ASB. Now this S will be replaced by ASB. Now this S will be replaced by AA. So see, this is what exactly I was saying. The triple AS triple B, you will get this thing, na? Triple A triple B, like this. Okay, so three times you have to apply this. Now one time you apply this. So S will be replaced by AA. So triple A triple B AA. Okay, now you will replace this small a, sorry, this capital A by AA. Okay, because you need two extra A's now. So triple A triple B A, and this A will be replaced by AA. Now this A will be replaced by null. So you will get 5 times A, 3 times B. Okay, so let me put entire thing on the one slide so that you can note it down carefully. Just note it down. Now next, N is less than M. So I think this should be homework for you, but still, because this is the recorded session, I will make it very fast for you. Okay, so I am just giving you answer. Just try to match it with your answer. So first thing is make equal ASB. Now B should be more na, so BA. Now A goes to BA or no. Similar procedures. Okay, just note it down. Next, S implies A. Okay, and let me say one thing more. In the previous slide itself, if we have N is greater than or equal to M, then what do you think? Then we will you can say we will delete this thing. So directly I can write, see, this is homework for you. Just try to follow it. If the language is A power N, B power M, such that N is greater than or equal to M. For this, you will write grammar like this: AS, B, or A goes to AA or none. Just try to follow it. This is homework for you. Please note it down carefully. Okay, and homework is you have to see why this grammar is correct. Okay, why for this language this grammar is correct. You have to note it down. Please, you should check boundary conditions only. Boundary conditions means null string must be present. So null is generated by this grammar or not. S implies A goes to null. Yes, null is generated by this grammar. Second should be AB. AB is generated. Yes, S implies ASB. S goes to A goes to null, and so on. Like this, you have to check. Okay. Now let's move to next question. N is not equal to M. This is again very simple. So what does this mean? This means where either A's are more or either B's are more. Okay. So first thing, again same thing. That means you will say ASB. So that equal is equal B's. Now stopper should be AA or BB. Okay. Now A goes to AA or null, and B goes to BB or null, like this. This is one of the way. I hope you can you can imagine what exactly I'm doing. Okay, please note it down. Now another way can be, see, what do you mean by not equal to M? Not equal to M means what? N is greater than M or N is less than M. Okay, so write grammar for N greater than M, write grammar for N less than M. and then you should apply or between them. So let me tell you one more way to write this grammar. See, I will write like this. I will write S1 implies A S1B or AA or A goes to AA or null. S2 implies A S2B or BB. B goes to BB or null. So this grammar is generating what? A's are more than B's. This is generating what? B's are more than A. That means N is greater than M. N is greater than M. This is the grammar. N is less than M. This is the grammar. So now what will you say? S1, S2 now. S1 is generating this thing. S2 generating this thing. So write like one thing like this. S1 or S2. That's it. So we get grammar for N is not equal to M. I hope you have got the point. So for union, or you can say or, you will apply this production rule, extra production rule, which will do things for you. Okay, now let's move to next question. A power n, B power n, C power m. Again, this is very, very simple. See, the similar idea which I have used in this slide, I will use the similar idea here. A power n, B power m. So first make this. Now see, n and m, there is no relation between n and m. N can be greater than n, n can be less than n, n equal to m, and so on. There is no relation. So let me do it for you. See, I will write S1 implies A S1B or null. So this will generate what? A power n, B power m. Now for C power m, you can easily generate, see, S2 implies C S2 or null. Okay. Now just apply SC. S1 is generating what? A power n, B power m. And S2 generating what? C power m. You have to concat them. You have to join them. So joining means what? S implies S1, S2. That's it. You will get the grammar. Okay, I hope I have made the point clear to all of you. Next, let's move to next slide. A power n, B power m, C power n, D power m. Again, very, very simple. Okay, so what will you say? S1 implies A S1B or null. Okay, S2 implies C S2D or null. Join them. S implies S1 S2. That's it. Okay, very, very simple. Next question. Okay, let me give you one more good example. Okay, and let me see that if you are able to design grammar for it or not. A power n, D power n, B power n, C power n. How will you design this? This is very, very easy case. Okay, so let me do it for you. A power n, D power n, B power n, C power n. So what do you think that A and D should be equal now? So S implies ASD. Okay, so ASD, you will apply multiple times, you will get A's and D's are equal. Now you want this in the middle. If you want this thing in the middle, then I will say S will go to B S1 C. Okay, and or you can say C such that I am writing n comma m greater than equal to 0. So if you are getting n comma m greater than equal to 0, okay, so let me do it properly. Now you will say you will move to S1. Now this S1 will produce B S1C or null. Okay. See, this is your homework. Please try to check that why this grammar is correct for this language. Okay. Please try to this if your concepts are clear. If you have understood properly, see this thing. I have given a lot of stress on this thing, that in the middle you will get the A. If you are able to follow this thing, then obviously you can guess the right thing. Okay, so please do it yourself. Next question. W transpose W belong to AB star. See, this is what, see, AB star means what? String over A and B. So if W is AB, then W transpose will be what? BA. That means opposite of it. So AB BA. This is an example of W transpose. Another can be, if W is A, that W transpose will be A. And if W is B, W transpose will be B. Since AB star is present, so we can have null also. If this W is null, then W transpose is also null. Okay, so on, and let me take this A double B, then double B A, and so on. So see carefully, all these are what? Palindromes. Palindromes means what? See, null dot null is null only. This will be double B, this will be double A, and this will be A B B A, and this will be what? A double B A. So all these are what? All these are palindromes. Palindromes over A and B. So now the grammar will be what? So this language is what? Palindromes. Now length of the palindrome. What do you think length of the palindrome will be what? Length of the palindrome will be even. Why it will be even? Because if W length is X, then W transpose length will be also X. X plus X will be 2X. So 2X means what? Even. So we will have even length. So the question is about generate even length palindromes. So how will you generate even length palindromes? See carefully. See carefully. This is very easy case. See, if you want to generate palindromes now, so W here we have W and here we have W transpose. So if W is starting with A, then W transpose will be ending with A. Okay, so let me do it like this. Say A, then we need BB. If second symbol is B of W, then W transpose second last symbol will be B. So second symbol of W, second last symbol of W transpose. Third symbol of W, third last symbol of W transpose. Say fourth symbol of W, fourth last symbol of W transpose. Fifth symbol of W, fifth last symbol of W, and so on. So now I think you have already guessed that how I'm writing this. Okay, so I think you have noted down carefully. See, let me do it one more time. A B B A B B like this. So what is this? S implies ASA, BSB, or null. That's it. So this is the grammar for generating palindromes, even palindromes over A and B. If you are not able to follow, then please rewind the video and watch it again. I have said this thing many times. Okay, so A. Now in A, S will be replaced with BB. Now S will be replaced with AA. Now again S will be replaced with BB, and so on. So I think you have got the idea. Okay, this is even palindrome. Next is odd palindromes over A and B. Odd palindromes over A and B, again very simple. See, ASA, BSB. Now if you apply these two productions, then obviously you will get even length. So odd length means what? Stopper it can be A or B. Okay, that's it. So let me give you some examples. See, A, B, B, and A. This is an odd length palindrome. Okay, then A, and B, 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 B. This is again odd length palindrome. So how this is odd length? W transpose, and in between we have either A or either B. Let me use different color. So in between we can have either A or either B. In between means what? Stopper. Stopper should be A or B. I hope I have made the point clear. Please note it down. Okay, and if you are still not able to get all these things, then please rewind the video, watch it again, and try to take some examples. You will get the idea. So this is again homework for you. You should be able to play with all these things, and you should be able to answer that why this grammar is correct for odd palindromes. Why this grammar is correct for odd palindromes. This is homework for you. Okay, next, all palindromes over and B. Again, very simple. Please pause the video and do it yourself. S implies ASB. Sorry, S implies ASA, BSB, or A, or B, or null. That's it. Odd or even. Okay, so a palindrome can be either odd or be either even. So apply everything. Okay, so you will get the answer. So this will be all palindromes over A and B. Okay, any palindrome, you can generate any palindrome with this grammar. Okay, now let's move to next question. A power n, B power m, C power n plus m. How will you write this? How will you write grammar for this? Again, very simple. See, let me give you some examples. A power n, B power m, C power n plus m. So C is sum of A and B. See, if I write double A, B, then C should come 3 times. Okay, if I write A triple B, then C should come 4 times. So there is no relation between number of A's and number of B's. There can be any number of A's and any number of B's, but the sum of A's and B's should be equal to number of C's. How will you write grammar for this? See, let me write it carefully, then I think you will guess it. AC, 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 BC, BC, BC. So see what you are getting. See, 6 times A's and 6 times B's. Sorry, 6 times A plus B's. Sum of A's and B's is 6. And sum of C is also 6. So that's it. You will get the answer. So I hope you have guessed it right. ASC. So you will get AC, 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 AC like this. AC, AC, AC like this. Now you want to get BC, BC, BC. So just do it this way. S1. S1 goes to B, S1, C, or null. That's it. So you will get the answer. Okay. So this is homework for you. You have to check it out yourself. why this grammar is correct for this language. Okay, just take some string and try to check and so on. So the more you think, the more you get. This is the basic funda of writing grammars. Okay, the more you think, the more you get. Next is this. Again, very simple. See, I will directly write string AC, AC, AC. Now again A, B, A, B, A, B. So see here. So sum of B's and C, sum of number of B's and number of C's is equal to number of A's. Again, very simple. Okay, so you will write grammar as S implies A S C or S1. S1 goes to A, S1, B or null. That's it. So again, homework for you. Check it out yourself that why this grammar is correct. Next, see B. So I think this should be homework. You can do yourself, but still, because this is a recorded session, so I must write grammar for you in a very faster manner. See, S implies A S B. So you will get A's and B's as equal. Now you want B and C, na? So you will say S. See, this is S1. S2 implies what? B S2 C. Now S will go to S1 S2. See, this is concatenation type. I can write it like this also: A power n, B power n, then B power m, C power m. I have already written grammar like this. Please rewind the video. See, this is the grammar. This is the language. For this language, I have already written. This was the grammar. So similar grammar, no? This is the similar grammar. Okay. So I hope I have made the point clear to all of you. Okay. So please see this B power n, B power m. So this is nothing but B power m and so on. Please. This is homework again. Please, you have to check it yourself. Next, A power n, B power m, C power n minus n. This is a twisted question. If you are able to think this, then I think you are through. Okay. So you will get good marks in your TSC subject. Please pause the video and try to think about it. How we are getting this thing. So see carefully. A power n, B power m, C power n minus n. So just add them. Add these powers, you will get A now. So I can write it like this also: A power n plus m, B power n, C power m. And I have already told you how to write this grammar. Okay, so just twist it, you will get the answer. Again, I am repeating: A power n, B power m, C power n minus m. So just sum these power. N minus m plus m will be what? It will be n only, and n is what? A. So I can say that A, number of A's is nothing but sum of B's and C's. So this is nothing but like this only, and I have already told you how to write grammar for it. Okay, so please note, try to write the grammar yourself. Next, W LG is equal to W such that NAW is equal to NBW. This means what? Pause the video and try to think about it. This is what? Number of A's and number of B's should be equal. Okay, so we can have mingle up. We can mingle up number of A's and number of B's here. Okay, so let me give you idea. AB string should be in the language. BA string should be in the language. AB should be in the language. BA should be in the language. BB AA should be in the language. ABBA should be in the language. Dot. So any possible string which have equal A's and equal B's should be in the language. So how will you write it? So one obvious way you will think that S implies ASB. So it will generate equal A's followed by equal B's, and you write BSA. So equal B's followed by equal A's. Okay, and stopper should be null. So I think you have written the grammar, but actually this grammar is wrong. Why this grammar is wrong? Because if your fundamentals are clear, then you will be able to guess that if you apply this production first time, then that string will start with A and end with B. If you apply this production first time, then that string will start with B and end with A. See, if you are not able to get it, let me do it carefully for you. If you apply this production, then A, S, B. Now this S will be replaced now. So you will get something here. So string will start with A and end with B. This is confirmed. Similarly, if you apply this production, then you will get B, S, A. Now start with B and with A. Now this S will produce something. So what I can say that this string will start with B and end with A. This is confirmed. Now, but the equal, if we have all possible strings for A and B which have equal A's and equal B's, then that string can start with A and end with A also, like this. So this string, I can guarantee you that this string cannot be generated by this grammar. So this grammar is wrong. Okay, I hope I have made the point clear to all of you. So this grammar is wrong. Why this grammar is wrong? Because if you apply this production first time, the string will start with A and with B. If you apply this production for the first time, then it will start with B and with A. So what about those strings we start with A and end with A? And what about those strings we start with B and end with B? So you cannot generate all those strings with the help of this grammar. So now what can we do? So now the need is, see, this production rule will do what? A's and B's are equal, but A's followed by B's. This will generate what? B is followed by A. So let us combine these two. You will get the answer. How will you combine this? Just write one more production here, or let me do it properly. I will write S implies A as B. So A as B means what? A equal A is followed by equal B. B as A means what? Equal B is followed by equal A. And null, so you can terminate it. So this is the grammar. Just apply one more production, that is SS. So you just combine these two. If you combine these two, then you will get all possible strings over A and B which have equal A's and equal B's. Just try to think about it. You will get each and every string. Okay, if you want ABBA, this is very, very simple from this grammar. ABBA, na? So AB, BA, so S goes to SS. Okay, so what will you do? Okay, let me do it properly for you. I will give you just basic idea, and then it should be a toy for you. You should be able to play with it. ASB, BSA, S goes to null, S goes to null. Okay, so what will you get? ABB. Just try to see it properly. ABB string, you are getting it. Okay, so you just name the string of equal A's and equal B's, and I will be able to generate that string with the help of this grammar. This is homework for you. Just try. You have to check it out yourself. So this is homework. You have to check why this grammar is correct for equal A's and equal B's. Okay, so please note it down carefully. Okay, or let me do it on one slide so that you can note it down. Okay, now next, A power n, B power n, C power n. See, this language, okay, this language is what? Equal A's followed by equal B's followed by equal C's. So let me tell you one thing. If you have more than one infinite comparison, why infinite? Because language is infinite. Huh? If we have more than one infinite comparison, then language is not CFL. Then language is not CFL. Please note it down carefully. If we have more than one infinite comparison, language is not CFL. Here we have more than one comparison. See, A's and B's, one comparison, then B's and C's should be also equal. Okay, so if you think that, sir, we can write, obviously we can write grammar for this. Now if you try to write, see, I am saying you with guarantee that you cannot write grammar, or you can say you cannot write context-free grammar for this language. See, if CFL means what? You should be able to write context-free grammar. So I am saying that language is not CFL if you have more than one comparison. Here we have more than one comparison. Language is not CFL means what? You cannot have context-free grammar which can generate this language. You cannot have context-free grammar which can generate this language. If you want proof, then I can give you very simple. Simply, I can say, of course, I'm not going to formal proof. I will give you just a hint about the proof. If you think that, sir, I can write grammar, then just try to write the grammar. For A's and B's are equal, you can easily write S implies A as B. Okay. Now what about C? How will you compare C? Okay, so you want equal C's also. Now you will say, sir, no problem. I will write here S1 A, S1 B, and S2 goes to C, S2. And now here also null, here also null, and S goes to S1, S2. If you think like this, then actually this grammar will generate A power n, B power n, C power m. You cannot compare A's, B's, and with C. Okay, because see, there is no compulsion on how many times you apply any production rule. There is no compulsion on how many times you apply a production rule. So I can apply A S B 100 times, and I am not, and from S to U directly apply null. Then you will get A power 100, B power 100, and C power 0. Okay, so we cannot guarantee A, B, and C all are equal with the help of this grammar. Okay, So hence I'm saying that this language is not context-free language. That means you cannot write context-free grammar generated in this language. And the most important part is that you should be able to identify that this is not CFL. So I have given you shortcut that more than one infinite comparison, the language is not CFL. Okay, I hope I have made the point clear to all of you. Okay, and I'm not going into construction of this grammar, so you should be able to write context sensitive grammar for it. So I will say that language is CSL. Why this is CSL? I'm not going into proof of all these things, because if you want to prove that this is CSL, then you have to generate a context sensitive grammar which can generate this language. And since this is a basic course, so I'm not going into detail of how we can write context sensitive grammar which can generate this language and so on. Okay, so this is out of scope of this course. This is a basic course on, or you can say basic fundamental course on TOC. This is not advanced course. In advanced course, I will teach that how I can have a context sensitive grammar which can generate this language. Okay. Now see, I have written this thing that more than one infinite comparison, the language is not CFL. Example is this. Okay, let me different color here. See here we have A's and B's one comparison, B's and C's another comparison. So we have two comparisons. So hence this is not CFL. Again, see here A and B's are equal, and A's and B's which are equal, these should be greater than C. Now. So that means what? We have two comparisons here. Again, this will not be CFL. So cross it. This is not CFL. See here A, B, C, D. We have three comparisons. A and B should be equal. B and C should be equal. C and D should also be equal. So again, this is not CFL. Okay. I hope I have made the point clear to all of you. Sorry. So non-linear. Okay. Next point is non-linear infinite comparison is not CFL. See, I am trying to explain that how you can say that this language is CFL, how you can say this is regular, and so on. This is identifying the language. This is very, very important part of your TOC. Of course, I'm doing the basic or fundamental course on TOC, but still, I think that I should give you some idea about how will you check that this is CFL, how will you check this is CSL, how will you check this is regular, and so on. So I am explaining all these things. See, non-linear infinite power, then again, this is not CFL. Non-linear power means what? A power n square. This is not CFL. A power 2n, A power 2n. This is not A power 2 power n. Sorry for that. A power 2 power n. This is not CFL. So let me tell you one thing. What about A power 2n? Such that n is greater than equal to 0. This is regular. Since this is regular, so this is CFL also. Please try to remember Chomsky hierarchy. If language is regular, then obviously it will be CFL. Then obviously it will be CSL, and so on. This is regular, then obviously it is CSL, CFL also, and CSL also. Okay, so how this is regular? I can write regular grammar for it. Very, very simple. See, 2n, na? 2n means what? Even A, so double AS or none. That's it. This is a regular grammar. You can check it out. Okay, so since this is regular grammar, so obviously this is context-free grammar also, and this is context-sensitive grammar also. So hence this language is regular also, CFL also, CSL also, and so on. Okay, so I hope I have made the point clear. Okay, so for regular, just remember one thing: there should be no comparison at all. For regular, let me write a few points for you. For regular checking means what? There should be no comparison. There should be no comparison. Or if there is a comparison, then that should be a finite times. Okay, let me tell you one more thing. In the previous slide, I have said that this is not even CFL, this is CSL, A power n, B power n, C power n. But if I write A power n, B power n, C power n, such that n is less than equal to 1000. So this is a finite language. And I have already told every finite language is regular. So obviously this will be regular. Since this is a regular, so obviously this will be CFL. This is CFL means that obviously this is CSL also, and so on. Okay, so please try to remember all these things. That's why I'm writing infinite comparison. Okay, I'm again and again using infinite comparison. So regular means no comparison at all, or you can have finite comparisons, no problem, but infinite comparison not. Okay, regular means no comparison. Okay, or linear power is okay. Linear power is also regular. Linear power means what? A power, say A power n, okay, A power 2n, A power 2n plus 3, A power 2n plus 3, or A power 6n, A power 6n plus 5, dot. All these are linear. Linear means what? I hope you should remember ax plus b is linear, na? Linear function. Okay, so power of x is linear polynomial. Degree 1 polynomial is linear, na? So x power 1, na? Okay, so I hope you remember all these things. So a power x plus 1, x power 1, or you can say just leave this. Na? It will confuse you. So linear means what? Just try to remember. If you do not know algebra and so on, then just remember ax plus b is linear. A and b are constants, and a cannot be equal to 0, but b can be equal to 0. So that's why I have written 2n, an, and a 2n plus 3, 6n, 6n plus 5, dot, 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 dot. All these are regular. So this is a basic shortcut to check the language is regular or not. Again, there are lots and lots of things, but again, I'm saying that this is a basic course. In advanced course, I will teach all the ways, or you can say in exhaustive way, I will teach you all the ways to checking the language is regular or not, language is CFL or not, CSL or not, and so on. Okay, but this is a basic course. So I am just giving you hint or idea. See here. This is so non-linear power means CSL. These all are CSL. Okay, non-linear power means CSL. This is also CSL. 2 power n, 2 power n. This is 2 power n. N factorial, again non-linear power. So this will be CSL. CFL, these are not CFL, these are CSLs. Okay, these are CSLs. A power n square, b power n, again non-linear power. So this won't be a CFL, it will be CSL. Okay, I hope I have made the point clear to all of you. Now please try to note it down. I will put everything on one slide. Please note it down. Next. Okay, so that's it. So this is all about your this lecture. I hope this lecture is pretty short, but it will give you lots and lots of idea about how we are constructing grammar and so on. Okay, so this was very important lecture of TOC. That's why I'm keeping it short, so that you will be able to follow each and everything. Okay, in the next lecture, I will jump to the next topic of TOC. Okay, that will be the closure properties of languages. Okay, thank you so much. Bye bye.